In the vast, silent expanse of our galaxy, there are countless worlds we can see, orbiting their parent stars in a predictable, cosmic dance. But what about the worlds we can't see? The ones that drift alone in the eternal night of interstellar space, untethered from the warmth and light of any sun? These are the rogue planets, ghost worlds cast out from their homes, and they are far more common than you might imagine. For every star you see twinkling in the night sky, astronomers believe there could be dozens or even hundreds of these lonely planets wandering the void. They are the ultimate cosmic nomads, traveling through the darkness for eons. Their existence raises profound questions. How do they form? Could life, against all odds, find a way to survive on these sunless worlds? And what would happen if one of these dark wanderers passed through our own solar system? To understand a rogue planet, we first have to understand how a planet gets lost in the first place. Imagine a young, chaotic solar system billions of years ago. It's a cosmic construction site filled with dust, gas, and newly forming planets jostling for position. In this turbulent environment, gravitational interactions are like a high-stakes game of billiards. Young, massive planets, like gas giants, have an immense gravitational pull. As smaller planets swing by, they can be flung around like a slingshot. Sometimes a planet gets a gravitational kick that sends it into a more distant, stable orbit. But other times, the kick is so powerful that it accelerates the planet beyond its star's escape velocity. It breaks free from the gravitational chains of its sun and is violently ejected into the cold, dark abyss of interstellar space. This process is called planetary ejection, and it's a brutal, chaotic event. A world that once had a sun, a potential source of light and warmth, is cast out into a solitary existence, destined to roam the galaxy alone for billions, perhaps trillions of years. Detecting these rogue planets is incredibly difficult. They don't shine with their own light, and they don't orbit a star that would illuminate them. They are tiny, dark objects against the near-perfect blackness of space, like finding a single speck of dust in an enormous dark room. So how do we find them? Astronomers use a clever technique called gravitational microlensing. According to Einstein's theory of general relativity, massive objects bend the fabric of space-time. When a rogue planet passes directly in front of a distant star from our point of view, its gravity acts like a lens. This microlens briefly magnifies the light from the background star, causing it to brighten and then fade in a very specific, predictable way. This fleeting flicker of light is the only clue we have that a dark, unseen world has passed by. These microlensing events are incredibly rare and require immense patience and constant monitoring of millions of stars. But each time we detect one, it confirms the existence of these invisible wanderers and helps us estimate just how many are out there. The numbers are staggering. Our Milky Way galaxy is estimated to contain over 100 billion stars. Current models, based on microlensing data, suggest there could be trillions of rogue planets drifting within it. They are, quite possibly, the most common type of planetary body in the galaxy. A world without a star seems like the last place you'd ever expect to find life. Without a sun, the surface of a rogue planet would be frozen solid, plunged into a permanent night colder than anything we can imagine. The surface temperature could drop to hundreds of degrees below zero. At these temperatures, any atmosphere would freeze and fall to the surface as snow. It would be a silent, desolate world, seemingly devoid of any possibility for life as we know it. But the story might not end at the frozen surface. What if a planet has its own internal heat source? Many planets, including Earth, generate heat from the radioactive decay of elements deep within their core. For a large rocky rogue planet or one with a massive metallic core, this internal furnace could persist for billions of years. If this rogue world is also massive enough to hold onto a thick, insulating atmosphere of hydrogen and helium, it could trap this internal heat. While the upper layers of the atmosphere would be frigid, the pressure and temperature closer to the surface could be just right for liquid water to exist. This creates a fascinating possibility: a world with a surface ocean, but no sun. It would be a planet of eternal darkness, yet potentially warm enough for life to begin. But there's an even more compelling scenario for life on a rogue planet. Consider a world with a vast subsurface ocean, hidden beneath a thick crust of ice. We see examples of this in our own solar system, like Jupiter's moon Europa or Saturn's moon Enceladus. These moons are far from the sun, yet they have liquid water oceans thanks to tidal heating from their parent planets. A rogue planet wouldn't have a giant planet to warm it, but it could rely on that same internal radioactive decay. A thick ice shell miles deep would act as a perfect insulator, protecting the liquid water ocean below from the absolute zero temperatures of interstellar space. Deep within this dark, sunless ocean, hydrothermal vents could dot the seafloor, just as they do on Earth. These vents would spew out heat and a rich cocktail of chemical nutrients from the planet's core. On Earth, these deep-sea vents support vibrant ecosystems teeming with life, completely independent of sunlight. Life in a rogue planet's ocean could follow the same blueprint, powered not by a star but by the planet's own geothermal energy. It would be a self-contained biosphere, drifting silently through the galaxy. The life forms in such an ocean would be unlike anything on Earth's surface. They would have no concept of day or night, no seasons, and no sun. Their entire existence would be shaped by the darkness, the immense pressure, and the chemical energy bubbling up from the planet's heart. This raises a tantalizing thought. Perhaps life is not an exception tied to the gentle warmth of stars, but a resilient force that can take hold in the most unexpected and seemingly hostile environments the universe has to offer. With trillions of these dark worlds wandering the galaxy, the question inevitably arises: what are the chances of one passing through our solar system? Given the sheer number of rogue planets, it's not a matter of if, but when. Astronomers have calculated that, on average, a star-sized object passes through the Oort cloud, the vast icy shell, at the edge of our solar system every million years or so. For smaller, planet-sized rogues, these passages would be far more frequent. Most would pass through without us ever knowing. Their gravitational influence too small to cause any noticeable disturbance. They would be silent ghosts, slipping through the outer darkness of our system and continuing on their endless journey. However, a close encounter with a massive rogue planet, one the size of Neptune or Jupiter, could have catastrophic consequences. It wouldn't need to collide with anything to wreak havoc. Its gravity alone would be enough. As it passed through the Oort cloud or the Kuiper belt, its gravitational pull could disrupt the stable orbits of countless comets and asteroids. It could send a shower of these icy bodies hurtling towards the inner solar system, dramatically increasing the risk of a major impact event on Earth. If a large rogue planet were to pass even closer, through the heart of our solar system, the results would be devastating. It could destabilize the orbits of the planets, potentially flinging Mercury or Mars out of the system entirely, or pulling Earth into a new, inhospitable orbit, either closer to or farther from the Sun. The good news is that the odds of such a catastrophic close encounter are incredibly low. The solar system is a vast and mostly empty place. A direct hit on the planetary region would be an astronomical long shot, an event that might not happen for many billions of years, if ever. Nevertheless, the presence of these rogue worlds adds a new layer of dynamic uncertainty to our cosmic neighborhood. They are a constant reminder that the galaxy is not a static, clockwork mechanism, but a living, evolving place full of wild cards and unseen travelers. The study of rogue planets is still in its infancy. They represent a new frontier in astronomy, pushing the limits of our detection capabilities and challenging our definitions of what a planet can be and where life might be found. Each new discovery, each faint flicker from a microlensing event, adds another piece to the puzzle. We are just beginning to map this invisible population of worlds, the lost children of the galaxy. They are a testament to the chaotic and violent history of planetary formation, and they offer a glimpse into a different kind of existence. One lived in perpetual darkness, but potentially warmed from within. Perhaps one day our future technologies will allow us to see these worlds directly, to study their frozen surfaces and perhaps even probe the dark oceans that may lie beneath. What secrets do these wandering worlds hold? Could they be home to forms of life so alien we can barely conceive of them? Or are they just sterile, frozen relics of a violent past? These are the questions that will drive astronomers for decades to come. As we continue to peer into the dark, searching for the ghost worlds of the galaxy. Thank you for joining us on this journey to the darkest corners of the cosmos. If you find these cosmic mysteries as fascinating as we do, be sure to explore more of our content here on Space Repo.